Welcome to our brand new series where we explore key conversations around the future of our energy. So whether you already work or are part of this industry or are just curious to know more about how it might affect our everyday lives. I'm your host, Hamza Ansari, a graduate consultant at EA Technology. And today in this very first episode, Predicting the Unpredictable, we'll be talking about three things. We'll be looking at how is this global transition to net zero affecting our energy usage? And then as a result, what challenges is the industry facing? And how can smarter tools and technologies, such as network visibility, prove to be essential solutions in order to tackle those challenges? With me today are my colleagues, Anna Duran, who is our product manager, and Sebastian Lindmark, who is our strategy lead, both on the Visident monitoring side of the business. And they'll be giving us their unique perspective on the points I mentioned earlier. First of all, thank you both for being here. It's great to have you today.
Thank you for hosting.
Thank you, Hamza.
I'd like to start off by looking at net zero. We know that the climate change is affecting us increasingly day by day. And tackling those challenges is essential or critical to society as a whole. We see companies trying to hit net zero by 2030. We see even countries having ambitious targets to hit net zero by 2050. But now focusing on the big picture, what are some of the main challenges, particularly the energy sector is facing to reach those targets, would you say?
It's a good question. So if we look at achieving net zero, it requires decarbonization of every major sector in our economy, transports, building and heating, industry, manufacture, agriculture, electricity supply, waste management. These are all big sectors, but when you dig into their sources of emissions, a good chunk of it is the emissions associated with the combustion of fossil fuel for creating energy. So, that makes the role of the energy sector at large both pivotal and challenging. So the core of the challenge is that the energy sector needs to enable all of these sectors to decarbonize and transition to alternative sources of fuel, but making that transition so that it is not only sustainable, but it's also commercially viable and economically competitive. So, that requires a fundamental transformation of our energy system, from building out different forms of generation to distribution. And you're looking at different types of energy resources. You have hydrogen, biofuels, and other clean fuels. But where we're seeing the biggest change is a mass electrification of end uses that were traditionally powered by fossil fuel.
That's actually a great insight, because I was reading in a report that the total energy demand as of now for electricity accounts for about 20%, but that's expected to rise to about 70% by 2050. Now, that's a massive increase, and I think we're already seeing that through EVs and solar panels, etc. But then we get the impression that the electricity industry is critical. But what are some of the unique responsibilities that is upon the electricity industry to reach our targets then?
So I think the electricity industry is really the backbone of that transition to net zero. And that's what is going to enable the low carbon and low cost infrastructure to come into place that will empower both consumers and businesses to go through that decarbonisation process. And as we moving away from that fossil fuel usage to more sustainable and low carbon sources, like we talked before about wind, you mentioned about hydro, solar, and I think possibly nuclear is something that we should put on the mix as well. We clearly are going to reduce emissions at source, which is something we need to do. So we need to ensure that the transition is done in a clean manner, but also in a reliable way. And one of the issues that I see, and you mentioned there, Hamza, is the big increase on electrification and that big step between 20 and 70%. If we put in the mix the electrification of transport and the heating sectors, then we need to ensure that when we move that to the electrical system, we're able to maintain that reliability. And I think in order to do so, we will need a massive influence from flexibility and innovation from the operator side.
So when you say flexibility, what exactly does flexibility mean?
So I think we need to adjust to having different players on the market that can provide different types of generations. They can adjust that generation based on the demand that is being requested on each time. And from the consumer side as well, I think the demand needs to be as well adjusted. So being able to say, okay, we maybe could tell a certain time, so we may be able to use whatever we require at night time and so on. So being able to have that flexibility from both generation and consumer side to play the role and allow using better infrastructures without having to go to the traditional reinforcement.
No, that makes a lot of sense actually. But then the question comes as when we look at the network infrastructure, a lot of it was designed a few decades ago, some even 100, 120 years ago. Then the question comes as how are they coping with these rapid changes? Are they coping at all? Or if not, how are they limiting our ability to modernize both quickly and effectively?
So to give a sense of scale of this legacy infrastructure, the distribution network in the UK consists of about 800,000 kilometres of distribution lines. You know, that's the equivalent of being wrapped around the Earth 20 times, going back and forth to the moon. So it's a big network, which for time has worked so well that most people don't realise that it's there. But this network infrastructure was built for relatively predictable one-way power flows. You know, people's behaviour in terms of when they'd cook their dinner or when they'd come home from work is easier to predict than when someone wants to turn on their heating or when they want to charge an electric vehicle. So the strain on this network is not only greater, but it's greater with increased unpredictability. And the truth is a lot of that infrastructure wasn't designed for the scale of electrification that we're seeing. So many assets are not only approaching their intended lifespan from a condition point of view, they're also at a high risk of reaching their rated capacity. So you have a dual challenge of a lot of these assets need to be renewed anyway, but also a lot of these assets need to be upgraded or reinforced unless you pursue alternative solutions like flexibility and reduce that demand on the network. But it's a big but fun challenge to work on.
It is a big challenge, I have to say. And then that makes me think is that how do the operators go from here? Or what should they change or be doing differently? Because they can't obviously change the whole infrastructure. So what's the change that needs to come about?
So yes, you are right, Hamza. So building a little bit on what Seb just said there before, flexibility obviously is one of the options that I think operators need to take on board, but we won't be able to achieve all of that massive electrification we are looking ahead just by that. So undoubtedly, we will need reinvestment into the infrastructures. But having said that, I do think we need to target that reinvestment smartly enough. And for that, we will need to use the insights derived from the monitoring, specifically on the LV side of the network, where there is predicted to be more distributed energy resources growth and also faster demands happening. And additionally to that, I also think we need to invest further and further on digital twin models that can help us to plan in a more uncertain and dynamic environment that we are moving into.
If I can quote a recent study completed by the National Infrastructure Committee, under RIIO-ED2, the current price control period that the DNOs are under, the load-related expenditures, so the effectively the budget that DNOs can allocate for upgrading their assets because they're strained by load was equivalent to about 16% of their total spend, or about £1 billion a year across Great Britain. Now, what the National Infrastructure Commission was looking at was, with the growth of EVs and PVs, how does that need to change from 2025 to 2050? And what they came out to was it needs to double. So what is £1 billion a year actually needs to double to hit that need. So it just re-emphasises the need to invest in that infrastructure. What they also pointed out is around 60 to 70% of that future investment lies in the low voltage network. So it just highlights how much change is happening to that.
Which is the big majority, to be fair, of it.
But with that being said, it's not just driving large infrastructure investments or building smart technology. The heart of all this is people. So, the more network you build, or the more technology you build out, the more people you need and more engineers you need to drive those projects and get them off the ground. So I think it's widely recognised in our sector as well that there's major skills shortage, and that's another big challenge. Yes, whilst we need to invest more and build smarter system, we also need more people to join the sector.
So it's all about a matter of resources, isn't it, at the end of the day? A question that came up is, when you said low voltage, I think when I hear of low voltage, what defines low voltage? Does it depend on situation to situation, or is there a set standard that this is what low voltage is?
I think low voltage is determined globally by, in the UK we call it the secondary distribution transformer. So when you go from potentially medium voltage, which tends to be around 11 kilovolts, and you step down to what is the distribution side of the network, which is normally around 400 volts. LV, or low voltage, is the distribution side of the electricity sector, which is what ultimately is where all the end consumers and more the domestic side of like premises, the small commercial premises and so on are connected to. So we're talking about the distribution side of things.
Yeah, so that's like the main part of the network, you'd say, which is facing the biggest challenges with this transition.
I mean, the whole infrastructure is facing challenges. So when you look at connecting wind generation or large solar plants, that probably impacts upstream more. If you're looking to electrify major industry, that's definitely more at the medium voltage or high voltage. But when you look at decarbonising or electrifying heat, or when you look at electrifying transport, which are millions of homes and millions of cars, a lot of that electrification is happening across the low voltage network.
So Seb and you, Anna, I know you both closely work with network operators and owners. And if in one word I was to describe the challenge point, it'd be unpredictability. So having those key conversations with them, with these operators and owners, what would you say are their main pain points, or the most important uncertainties that they face today?
So I think they have a fair amount of uncertainties, to be fair, but a few that come to my mind are first the unpredictable of the distributed energy resources that Seb just talked about. What's the uptake of those and their behaviour? So we are talking primarily about where and when. And just to put an example into that, it's predicting, are we going to have in a year's time 1 in 10 homes having a heat pump, or is it 1 in 3? And are they going to be clustered, in which case they could potentially create some overloads in certain substations, or they're going to be more scattered around? So that thing will be one of the challenges. As we move towards using more renewable resources on the generation side as well, wind and solar, we have the unpredictability of the weather, unfortunately, and the volatility of it. So again, forecasting and predicting when generation and demand is will help us to as well fill back some lack of resources that, because of weather conditions, we may not have when we wanted to. Also, the electrification of transport and the heating is going to bring, you mentioned, Seb, differentiation on the peak demand, where we may go from traditionally 5 o'clock evening peak from more a domestic response to charging electrical vehicles, for example, at night. And again, localization of those demands are also going to change the shape of what we're expecting at the moment or what we're seeing currently. There is also, I think, the impact of the customers' behaviours and uptakes of solutions. So we talked about flexibility and we talk about innovations. I think those things are needed. And I think I mentioned this before, customers are essential to enable that transition. But we need to bear in mind that most of the times those customers need to be somehow incentivized and brought into programs that they can accept and that they can take part on. And perhaps, I don't know, the last thing that came to my mind, and by no means is the least important, is as well, with very few visibility of failure networks, predicting faults and outages is really challenging. And we talked about resilience and reliable networks, and that's one of the things that are key for operators and for us as consumers. So that is kind of some of the points that I can think could be a challenge and uncertainties the operators could have.
If I can build on it as well, you talked about weather with climate change, the weather impact on the infrastructure as well is highly unpredictable. So the need for building up resilience in the network and factoring that into design is a big challenge. So when you have rising temperatures, more unpredictable storms, in certain parts of the world we have increasing rates of bushfires. They're all things that impact our infrastructure, and the last thing you'd want is the infrastructure to further worsen those conditions. So I know in Australia and California, bushfires is a big issue on the infrastructure, but it's also a major consideration for how the electrical infrastructure doesn't contribute to bushfires too. So loads of challenges.
Loads of pressures on network operators as well. So it seems like DNOs are facing a lot of pressures. I mean, what you mentioned, be it environmental, fault management, capacity, even regulatory pressures. How must they evolve going forwards to face those pressures? Like, what do you think needs to shift?
So that's a big question, and for each of the problem areas that we've articulated, there might be slightly different ways they need to evolve. What we are seeing, at least in the realms of where we're working, is that a lot of utilities are following a model, monitor and manage type approach. And what I mean by that is you start by building a digital representation of what's happening across your network. It's a digital model where they understand how the system behaves today and how it might behave tomorrow. And the purpose of those models often are trying to figure out where the risks across the network are. So if you're building a capacity model, it might be figuring out where you have limited capacity or your network's running out of tolerance. If you're interested in the condition of the network, you're looking at fault-prone areas or high-risk areas. Or it could just be you're through doing so, you're finding major blind spots in the data. And based on those risks, you choose to monitor the network where you need better visibility or where you have those risks, and you either want to refine the model or get confirmation on what the model is telling you.
Yeah, but also data doesn't need to be perfect, isn't it? There is, I think, a misconception that until you have perfect data, specifically on the modelling side of things, you cannot do it. And I've been working on that, in that area for 5 years, modelling tools for DNOs to be able to connect new loads into it. And yeah, models obviously a representation of data that you put into it, but you can certainly get a long way from nothing at all to having some insights from it with some data in there. So I would encourage that is, taken forward as soon as possible.
Definitely, and it's a loop, isn't it? So as the network evolves, our understanding of the network evolves as well. So it's not a model, monitor, manage, and then stop.
Forget.
It's
right.
iterative.
That's right.
So you could refine that process, and but it's starting somewhere, and it's not waiting for perfect data to kick off that cycle. I agree.
That's right. And also, I think, again, from the modelling perspective, I think we have traditionally followed this approach of worst case scenario. And I think while that may have been, a good approach for a while, I do think we probably need to move into more probabilistically situation and scenario modelling instead. And in addition to that, as we are getting more and more visibility of the network through the monitoring, and that fits back into the loop that you're talking about, Seb, I think operators are also going to be able to use things like flexibility and also forecasting built into their own operations, especially when we're talking about more kind of locally situations.
No, that's actually really good insight. And you mentioned the word visibility there, which caught my attention. When I hear the word visibility, it has a sentiment of comfort in it, so as if you can see what's happening. What makes it so important for network operators to have that network visibility? I know some of it has already been touched upon, but are there any additional benefits that come along with it?
Certainly, I think that there is loads there to talk. So with real-time monitoring data, you can help prevent outages to start with, and you can as well reduce restoration time, so you can act fast under full response conditions. And when we're talking about real-time monitoring data and linking this to, I think the title of the podcast today, which is Predicting the Unpredictable, we are basically trying to use the data-driven insights to allow smarter decisions, or operators to do smarter decisions as to where they need to reinforce or upgrade or defer investments. And the link there is you monitor kind of simple signals of voltages and currents, and then what we do on top of that is extract from those based on our experience, primarily working in that sector for many decades. What is kind of the actionable insights that we can provide, in this case, to the operators for them to manage what we are predicting is going to happen.
So basically predictive insights.
That's right.
Completely agree. And visibility isn't just about seeing what's happening. It's about being able to make informed, timely decisions. So for the network operator in this context, it means knowing where the pressure points are. So allowing them to respond faster to faults, allowing them to optimize capacity and be able to make those investment decisions before, or making informed investment decisions before investing millions of pounds into reinforcement or repairs. Now, for the end consumers, so whilst we're at home, it's about reliability. It means fewer outages. It means less roadworks. It means faster restoration. So when the power does go off, it gets restored quicker. And it's being able to connect EV chargers, solar panels, heat pumps, without unnecessary delays or ridiculous charges. So that's where this becomes a bit more pragmatic.
For the people listening to this who might not be part of the industry, I guess this is where they come into the picture on how these problems are not just for network operators. By helping the DNOs or the network operators, we're actually helping the customers as well, with the points you mentioned.
100%, and I think Seb touched on that one. So the responses that I think, or the end game of all of this visibility impacts consumers, all of us, and if we benefit from fewer outages, faster restoration times, better connections or quicker connections, and also having a grid that is more ready, available for, again, add those connections. So when you want to have an electrical vehicle or, for example, connected heat pumps, knowing that, the grid is there and you can actually go ahead with it.
Yeah, makes sense. So what is the end result of, let's say we have network operator A and then network operator B. Network operator A has the advantage of having those predictive insights versus reactively responding to faults or any outages that happen. What is the end result of that network operator A having those predictive insights?
So I would say that predictive insights enable proactive maintenance and also planning capacity ahead of time that will reduce failures, and it will also optimize investments before the problems can escalate. So looking from a different perspective, because you can plan ahead, then that means that instead of reacting to faults or constraints after they have happened, then you can manage your resources more proactively. And hopefully that means that operators will have fewer emergency calls, they can manage their teams better, and also they can choose kind of solutions and more efficient interventions. That crucially is also going to allow the operators to align the operational, you mentioned before, the load and non-load related investments. So operators are not just going to fix what the problem is, but they are also going to be able to coordinate the solutions taken forward in a more holistic way as a business as a whole, I would say.
If I can just build on that, the network operator there would have more optionality. So we talked earlier about the resource constraints, both financially and people wise. By having that data, you can choose to allocate resource where it's most optimal. So instead of reacting and then having that peak demand of people issues, you can allocate that resource more effectively as well. So that planability, I'm not sure that's a word, but that's a major benefits of having those predictive
and
insights.
I think that's important. We you said before, Seb, about shortage of skill sets. So that I think is a very important point to take on board, is if we are able to manage better the resources that we have, that will definitely help with situation of having more requirements for engineers and skill.
Yeah, and I assume when you're able to manage your resources better, you have more allocation for new investments.
That's right.
And then that makes me think that what kind of investments become possible when you have that network visibility.
So I think we touched on it in bits and pieces, but the investment decisions can be multiple. It could be supporting faster fault detection. So if as a business, the utility is trying to drive down the number of customer interruptions or the duration of those interruptions, they can allocate more resource to drive that, and having data to back that resource allocation. And it can include smarter deployment of protection devices. So where do you maybe take out a traditional fuse and put in an auto recloser? It could drive either earlier or later intervention of the asset, depending on, you talked about load related and non-load related expenditure. You can make those decisions on I'll either drive my asset harder and then upgrade it, or I'm actually going to replace it quicker because I want to avoid the customer outage which is impending. So loads of different things that could be done, but broadly speaking, I'd probably put them into three areas. Improving operational reliability and safety, that's an investment area. Guiding load-related reinforcement where capacity is constrained, that's probably the second area. And then supporting condition-based asset strategies. And for that final one, at least in our world, the low voltage network, and particularly the underground low voltage network, has very limited condition data to back up those investment decisions. So I think one of the key areas that we look at how that data could be used is also within that condition-based investment strategy, which isn't feasible at the moment without the data.
That's right. Yeah, and it's also quite, I think, especially provided. So you need that experience and expertise and understanding of how the network operates and evolves over time, and how conditions are affecting faults and outages and so on.
No, that actually makes a lot of sense, because the impression I get is by having network visibility, it's many use cases in one, essentially, and you can and can be used by different DNO teams, so asset management and network planning, fault management operations. But let's talk a bit about tech now. So I know I'm switching the topic a bit. They say there's been a shift between something called centralized computing towards grid edge intelligence. Now, many people might not be fully understanding the term grid edge intelligence. For people unfamiliar with this term, how would you describe it? Or what exactly is it?
Yeah, it's. I will probably describe it as grid edge is what you can do localized, where you have all the data and you can interrogate that data and understand what is critical from that data. And I'm going to be a little bit more precise, and I think going into details of, for example, what we do here at Business Monitoring at LB. With our Business Hub, for example, we compute at grid edge, and that helped me explain a little bit the definition. We monitor the electrical network with a very high frequency. We are talking about 16 kilohertz.
Wow.
That put that into perspective is every second we sample the network 16,000 times. And again, to give a perspective of that, to smart meters sample one every 30 minutes. So you can see the big difference between high frequency sampling and, more eventually, I guess. But that high sampling that we do, we have an awful lot of data, obviously. But that data is required when you're talking about things like faults, for example, and pre-fault conditions. We actually need to analyze sine waves and see spikes on those. And those, we're talking about milliseconds. And grid edge really means that we are able to capture all of that data in our units in the substation, and those units are able to decide, they have the build logic internally to decide what is critical, what is not, what data do we need to then pass to the cloud, and what data can just stay there to be interrogated if you want it further. But it reduces the transactional movement of data, for that data from the device itself to servers, the cloud, etc. So grid edge, I will define it as that intelligence that you may have at the locality where the unit is that reduces data transactions.
I recall seeing some information on that about a product where we collect about 140 gigabytes worth of data from the substation on a daily basis, but we only transmit up about 50 megabytes worth of data on a daily basis.
That's a big...
It's a big delta, so you get the richness of 140 gigabytes worth of insights,
That's right.
but you're only shipping up the valuable bits, and that
But also
is
that
powerful.
is, and I think it's kind of something that makes sense. You are sampling the network, and there are times where there is nothing really to report on or to have a look at, because the network just behaves as you would expect. But it's that intelligence that's able to capture what are the things that are important that actually need attention. And that's the difference between all the data that's been collected and what actually has been
So instead of
exported.
sending all of that to the cloud and being processed, all of that is processed locally.
That's right.
And then only the essential bits are sent out.
That's right.
Are there any other practical benefits other than a lower cost data or better data management that come along with it?
Well, without turning this into a sales pitch for our monitoring equipment, at a high level, I can probably group the benefits of that grid edge into three buckets. So the first one is scalability and simplicity. So you're deploying tens of thousands of these devices, and you can deploy these solutions that have targeted insights and reporting not just raw data, but reporting insights, so the DNO can expand quickly without overwhelming central systems with a sea of data that they can't then post-analyze. So you get value off the bat. The second one is probably adaptability. So the challenges of the network today might not be the same challenges of the network in 10 years. And ideally, we want to deploy one monitoring device into a substation and leave it there for 10 years. And what you want is equipment that can evolve in its functionality with the network. So you could deploy new functionalities and insights to that device and do so without ripping out, replacing the hardware, or rebuilding core central platforms to accommodate legacy equipment. And finally, you touched on it, cost efficiency. So by processing the data locally, you reduce the burden on transmission, storage, and computing the data on a cloud server. Now, we mentioned scale, 140 gigabytes worth a day. That's the richness of the data that we're collecting. But it's not commercially viable to ship that data on a daily basis. So grid edge intelligence, you get the richness of the data, but you don't have to transmit and store it all centrally.
Oh, that's actually very interesting. I know we as a company operate mainly in the UK, but also globally. Some of the challenges we talked about, how can they differ at an overseas level? Like, are they similar, or how different can they be?
I mean, some challenges are shared globally. The growth of renewable technologies, the need for more resilient networks. They're global issues, but when we go into the specific context on challenges, this varies country by country or even utility by utility. So that means that the benefits and the use cases of the data differ too. What we are seeing, however, is that globally there is a need for better visibility of network infrastructure, but the why changes. So to give some examples, in Germany, there's a new government mandate around flexibility and control of consumer assets, but utilities need visibility of the actual utilization of the network, and that's where monitoring data comes in. In New Zealand, a completely different driver, where it's more around quality of supply issues and detecting things happening on the network before it could lead to failures. So whether that's pillar fires or pillar issues, it's trying to detect those signatures and prevent those. Some DSOs in the south of Europe, they're using monitoring data to resolve topology issues, so where they don't have good historical data on topology. In other parts of the southern hemisphere, there's a push to understand why there's rising fault rates or underground fault rates, and whether that's load related or condition related. And then finally, across Southeast Asia, we've found a strong push for faster fault response, so more around SAIDI and SAIFI reduction. So there's a common thread for the need of visibility, but how the utilities are using the data depends entirely on their local challenges and what systems they already have in place.
And I think that's the beauty as well of the monitoring, isn't it? Because by having that visibility of those electrical and essential parameters, then you can set all of these different kind of use cases and business cases and scenarios with systems like the monitoring that we can provide. Then you allow from that variety of solutions that you can provide with just one device and one installation. And I think that's something that is very important as well.
And I think that's where the real value lies, doesn't it?
That's right.
Yeah. Now my final question is to you, Anna. So as a product manager, I'm quite keen to ask you this. But what's your vision of where VisNet monitoring is going to look like, let's say, in the next 5 years?
Good question. And I think throughout the session, we probably wanted like a crystal ball. And here I would like one as well. But so I can talk from what my perception of the situation I would like it to be, I guess. And I personally would like to see VisNet monitoring being recognized globally as a trusted partner in grid digitalization. And not just as a provider of hardware, but a leader in delivering high-value, actionable insights. And we are expanding nowadays our footprint across international countries. And we are also setting ourselves very firmly in both the LB, but also increasingly on the HB monitoring space. And if we join that together with integrating as well seamlessly with our top tier digital twin platforms that we also can provide, I can see VisNet enabling distribution systems operators to make much smarter and faster decisions moving forward. And that can unlock potential revenues streams. It will help to accelerate decarbonisation, and it would also enhance grid resilience from the end. Another good point I would like to say is our competitive edge will lie in our data-centric approach, which means that we are able to transform the granular network visibility that we can get from the monitoring systems into powerful operational and also strategic intelligence that we can provide to these operators. And that is grounded by all the decades of the real world distribution system operator experience that we have gained through the years.
That's really good insight, Anna. You know, if I was to summarize this conversation we've had, I'd say that these are challenging but exciting times ahead. And sometimes, at least for me, it might feel a bit intimidating on, let's say if you look currently, how fast things are already moving and how much is to be done in such a short amount of time. But nevertheless, I think we can all agree that we're all part of this, regardless of whether we're part of this industry or not. We all contribute to this transition. And I can say that let's see what the future holds then. Thank you both for your detailed insights and unique perspectives. Me personally, as a graduate, I feel I've learned a lot, and I hope the people listening to this also feel the same. Thank you all for your time and attention. I hope it was both entertaining and educational, and we hope to see you back very soon.